Hey guys, how's it going? So today we're gonna be going through no load shedding. Ish. Okay guys, look, I have to go. I will be back after 2 hours. I don't know if it's stage six, maybe 4 hours. It depends. So yeah, sorry about this inconvenience. Anyway, bye. Okay, if you some of you might have not gotten that joke, but anyway, it's a joke whereby essentially in South Africa we face with this challenge whereby we have load shedding. So load shedding, you can think of it as like electricity is getting cut off, due to like high demand, and we don't have necessary resources currently in South Africa to meet that demand. We're working towards it. Hopefully things will work out. But yeah, that's like the current state. But yeah, I'm positive about such things. I think it's gonna work out. But anyway, so just to preview, guys, what we're gonna do today, we're gonna go build a residual demand forecasting model. So we're gonna try to actually be able to predict demand of electricity like maybe in 2 weeks or so. So given today, we can actually be able to tell what the electricity demand will be like in the next week, right? So that's what we're gonna do. Doing this essentially help us to be able to prepare and by allocating necessary resources, right? So that we can meet that projected demand for next week or 2 weeks or so, right? So this is quite a good technique. It's not something new. All the companies, I feel like they use this technique. It's called forecasting. So, but today I'm going to show you competition winning strategies that some of the Kaggle users have been using, and these are proven state of the art models and techniques. So it's going to be cool. Not only that, I try to do things differently, which is that I used economic factors, social factors. I feel like this is something that I try to do, which is different. Like you will see the code, and we try to use things like holidays and stuff like that. I didn't want to use supply features. I think Eskom provides supply features whereby they provide you with like wind capacity, all of the uh, uh, supply features, all of these features that has to do with like how they supply electricity. The thing is, using those features essentially was gonna uh, then I was gonna explain the demand based on supply. Then that's not something new. So I needed to come up with something new. Tell you guys, okay, I think the demand it's related to something like CPI, inflation, all of those economic factors, population, what's going on, right? Holiday, weekends, time, all of this stuff. So that's what I try to go into. And not only that, we're gonna see. I built this thing with Next.js. Next.js is very, very powerful for building UIs and stuff like that. And it actually works well with backend. So you can kind of like call your databases and build API on Next.js, so in the same code base. So it's pretty neat, right? But yeah, usually I prefer to have my own database where I build with Rust or Go, but especially if you're building like powerful scalable project, I think that's what you want to build use, right? But anyway, yeah, that's that. There's going to be a lot of things that you guys are going to grasp into this. So this will be more like a walkthrough and show you guys how it works. Before we get into it, I just want to say that you guys know that this channel is all about like preparing you for interviews and solving uh, software engineering, machine learning, data engineering projects, interview questions. I still feel like having project is still quite good, like something that you can show off, especially if the project is quite unique, it stand out. And this project here, I believe that it's unique, right? I'm not saying that it's special or anything, but it can help you to be able to, if you want to apply for data science job, stuff like that, and can actually be able to tell that guys, look, this is what I did, and this is, this is what I know, something like that. So you can use this project. I'll post the code on GitHub, and you can build it from scratch, and you can put it under your portfolio, and it's gonna help you get a job, right? That's how it works. For some of you guys, I have a second channel just to keep you guys updated. My second channel is called the AI Guy. This is where I cover like research AI research papers. If you're into AI and like you like to build like models from scratch, like something like that, check it out. It's quite cool. But yeah, That's that. Now let's get into the project. So before we start, just to give you guys some context, I'm working on this environment called Databricks. Databricks is well known, especially in the data engineering, data science community, alongside with Snowflakes. Essentially, it enables data engineers to write a very, very scalable Python code using PySpark. So you can think of this as like it distribute data to different clusters. By doing this, it enables data engineers to process very, very large amount of data. So so that's why we use it a lot. And the reason I'm also using it is because as much as we're gonna be covering data engineering project in this on this YouTube channel, so I want you guys to be familiar with this platform. And it's free. You can go and sign up. They give you 15 gig of RAM for free. So yeah, but if you don't want to use it, that's fine. You can use VS Code. This code will work. You can use Google Colab, any environment that you feel comfortable with. That's still fine. Okay, so so what I'm doing here is that I'm gonna import all of these libraries. To explain what they do, I think it will be better if like I show you the code so that when I explain, I can be able to link them. In that way, you get to understand actually what they do. So here, what we're doing is that we have this file here, which is holding our data set. So I'm gonna read this. It's a CSV file. By the way, you can actually go to this website called Eskom Data. So you can get this data, and you're gonna get a fresh data, so like the current data. So that's the good part. So in case you're watching this video in the future, you're gonna get like the current data. So that's fine. Just search Eskom Data, and you're gonna go to the website and you can sign up. I think they give you like 5 years of data, so all the way from 2018. But also upload this data on my GitHub account so that you guys can use it in case you don't get it. So yeah, we're just reading the data. I'm using Spark here to read in this data. So I'm getting this data as a data frame, just to kind of like show you how the data looks like. I think that will be fair. I'm just gonna open here so that you have a glance of how this data looks like and all these columns, right? So this is how the data looks like. We have dates, we have residual forecast, so we have residual demand, which is what we want to pretty much forecast. We have international exports, international imports, terminal generation. So these are supply related features. So what I've done here to help you guys, uh, I pretty much categorize these features, right? Uh, and some of these features are related to one another, and some of them are derivation of other columns. So you might want to avoid such things because you're going to cause data leakage. So I'm going to tell you that is. But anyway, just to get into the feature, what I've done here is that I've kind of like categorized them. So we have like temporal features, we have like interruption features. So we have this ILS usage. This has to do with like Eskom essentially cutting the electricity because of the same thing with load shedding. So these are something like that, right? Manual loading reduction. Um, and then we have these Eskom generation features. So these are all the operations, generation unit hours. So I think Drinkenspec, these are all the operations that we have there. I wasn't sure about this. I tried to Google this. Like I've never found this, what this feature means. So I kind of like interpreted it myself. So I think this might refer to the amount of electricity that is sent out to Eskom power station to customers who are not on commercial tariffs, because I think this non-com send out feature means that. So I'm thinking like things like schools, hospitals. This is like they fall under this. Anyway, uh, so then we have these supply generation. So these are like all the resources that generate electricity, whether it's through wind, whether it's through thermal generation, nuclear generation, all of these stuff. I group them into one and I put them here. Then we have these capacity features. So you can think of like, capacity as capacity, like wind install capacity, uh, what is it, energy resource capacity, Eskom capacity, and stuff like that. And these are demand features, right? So demand related features. There's this RSA contracted feature and residual demand feature. Then this is unplanned loss production feature. Essentially, you can think of like um, all the features that are related to, let's say, like the electricity was not available because of maybe there was a stoppage within the production of Eskom, something like that. And it could be due to unplanned because of maybe there was equipment error or something like that. But that's what this means. These columns mean. Then we have exports and imports. Yeah, this is like also uh, Excom buy electricity from neighboring countries. So those are going to help you out. So that's that. So what I did here was to link some of the project objectives, right? So some of the stuff that is possible. So you can, which is what we did, forecast demand, forecast supply. What you can do here is that you can add up all of these columns that are related to supply and you try to focus that. Then there's anomaly detection. You can try to use unsupervised machine learning model like isolation forests, k-means, PCA, to be able to see any anomaly within the data and you can cluster it. So there's so many ideas that you can do, right? You can do able to, you can also forecast some of the downtime, stoppages, all of the stuff, or whether there's going to be some sort of like stoppage in the production. You can focus that. That'll be cool, actually. You can do that, right? So I've kind of like left them here. But there's certain things that I want you to be careful of, which is that you need to avoid data leakage. I've also written here, which is that some of the columns essentially they are they are explaining other columns, right? It's like, think about it this way. I want you to think about it this way. Let's say you want to predict what is this? A revenue of a company, but within your features there's something like profit, there's something like cost, then essentially that is no longer predictive because you can do a simple calculation and get the revenue based on those features that you have. So what you want to do in this case is that you want to make sure that you avoid things like total something like this because they just the addition of this, right? So unless if you want to use total and you're going to discard these, that's fine. But that's what I was saying, right? So especially if you're going to do like some prediction, so that's what you should avoid. Anyway, that's what we have. So I've loaded the data and I've converted the data here to pandas. This is because I don't think we need PySpark because we the data can fit in memory, and the communication between clusters essentially can add up latency, so the code can be quite slow. So given that we have like 40 rows of data, so this is fine. I'm using pandas. So what we have here is that we're gonna have this test set. So Escom have evaluation data. So I'm just gonna run it for you guys. So they made predictions in the future. So we're gonna evaluate our predictions based on this. Okay. As you can see, right? So this data here is holding like all the predictions in the future. I think this is 2023 or 331. I know that today is the 10th. I don't know when you guys are going to be watching this video, but today is the 10th of April. So this data is pretty, what is it, 6 days, 15 days old, I think. 10 days old, yeah, I think. Yeah, 10. So, so that's that. You can get in your data. It's still fine. So don't worry about that. Anyway, we have this. So these are the predictions that have been made in the future, and then we that means our data set is going to be ending on the 25th of March because we have to make 1 week Eskom make 1 week forecasting, so we have to also make 1 week forecast. So that's that. That's fine. So that's that. What do we have here? I'm just dropping some of the columns. I think I don't care about this column because of it has to do with lockdown. I think. So as you can see, it has null value, so it's definitely fine. Um, then here I created this class South African holiday, uh, just so that I can capture the holiday. I believe that there's a this is was my assumption is that there has to be some sort of like relationship between electricity usage, especially when it's a holiday. So that's why I had to create this. But anyway, this is what I did was that we have New Year. Some of these holidays we know they are day, so it's specific day we know them. But when you have something like Easter, it's not specific. So what I did here was that uh, I I took like an Easter day because if it's Sunday from using this what is it, this Easter function. Then what I did to get Good Friday, because of it is 2 days before, then I tried to subtract 2 days from this Easter day, right? Then this is Good Friday. So this is dynamic because we're working with data from 2018. So I want to calculate Easter for every year. So I think that's why I had to do it in a dynamic way, including Family Day. I think this is whereby we gonna add 1 day, right? So to the Easter. These ones don't have a problem. These the holidays. I think we know them. 16 will always be 16. 16 June will always be 16 June. National Women's Day will be the 9th. So that's fine. But that's essentially here we can think of like this class is just gonna assign the holiday to our data set. So how it does that is that we firstly create this uh, timestamp, right? So it's very important to understand your data types. That's what we're doing here. And I'm extracting these features here, like time, minute, hour, year, day, and all of this stuff, which I'll show you in a second, how it looks like. Then we calling our class get a holiday. So essentially what we do is that we take a year and we take all the years from our data set and we pass them inside this South African holiday class, and it's gonna return all the holidays. And then we have this sa.getHoliday, which is df with dates. Then what we do is that we're gonna join that. Yes, we're gonna say pg.match with our data frame. So we join those holidays with our data frame. So the reason we give it yes is because if we can see here, what we're gonna do is that we're gonna look through for each year. As you can see here, we're gonna look through for each year, and for each year we're gonna get all these holidays because, like I said, Easter is different for each year, I think. Okay, so now your question might be, but how does this data looks like, right? Like when we transformed it. So this is pretty much how we roll here. I'm gonna run this guy. These are the transformation that we did, as you can see on the far right. So you can see that we have the year, we extracted the year, and you can see here it's a holiday. So where it's not a holiday, I wrote South African holiday. Where it is, I wrote the right holiday. Okay. Okay. Let's just. I'm just gonna try to filter this, right, so that we get to see actually meshed df dates. I'm gonna paste this. I'm gonna paste this column which is date, right, and I wanna say equals to 2019 because I don't think 2018 we started January based on the data set that we have. So instead, I'm gonna say 2019. Uh, the 1st of January, it's gonna be New Year, so this has to be a holiday, right? So yeah, this is what we have. So as you can see, the reason we have so many rows is because this data is hourly. Day. By the way, I forgot to tell you. Sorry about that. So it's hourly data. It's not necessarily a day data. So it's based on hours. But as you can see here, holiday is New Year. So right. So which means that our function works fine. Um, so that's cool. So what do we have here is CPI. I'm gonna share all of you guys with this data also. This is something I feel like it's unique and it's very very powerful technique that you should also use. I feel like in your project is to use economic, social factors, interest rate, inflation, cost of electricity, population, all of the stuff, and then this way your model gets to be very very robust and it can you can explain demand or some of these factors based on this. I feel like if you use supply, then you are not gonna like supply features. You're not gonna tell like you're not gonna tell them something new, right? They already know that oh we can't meet the demand because we don't have enough resources, right? So that's not something new. They already know that. But if you're gonna tell them something new, like, okay, I think there's a relationship between this, they're gonna be excited, right? So that's what I think as a data scientist, that's how you stand out and you kind of like think about these different ways to enrich your data, right? So that's cool. So as you can see, this is what we have. You can see this is consumer price index. Some of you might be like, you might want to see this data, right? And that's like the thing. And so I'm not gonna skim over this. I just want you guys to see it so that you get to see actually how the CPI data looks like. Uh, it was hard, guys, to get this data. Like the CPI, the population. Oh, it was very very difficult. Um, I will leave the link where I got it. I even forgot because I have to scrape like so many websites. I'll share the scripting scripts that I wrote with Python to scrape the website that have this information. But essentially, this data, guys, you can see that it talks about rice price, loaf of bread, all the way, all the way from 2017. So we don't know if there's a relationship between electricity and this, but we're gonna add it because we don't know. So our assumption is that maybe if like prices of food increases, maybe it's related to electricity. We don't know that, but that's why we're getting the data. But you can see that this data is quite good. I like it, and you can see that it's not nice, meaning that it's not clean. So we have to like this code that you're seeing here. It's gonna try to make it clean so that we can be able to join it with our data, right? So that's what we're doing here. Just to kind of like walk you through it, I'm saying that if a column here, if a column, any column that start with M, I want to cast it, then I'm saying that I want to group all of this stuff and sum them because I want to sum them by this is a year and a month. Um, then I'm gonna do that. Then I'm removing. Yeah, this is what I'm doing. I'm removing this M. What is it? It is M. This thing here because of PySpark. When you're working with PySpark here, essentially when you're grouping with PySpark, it's gonna leave this. I think you guys will see that, especially when you're running this code yourself. You'll see that it leaves this something like this, and it tried to write the column in the middle because you used the group by. So now I had to remove that sum that it put there. The goal was to remove this M. I don't want this M because I care about this date 2017 and 01, so a year and a month. And when I get that, I can actually be able to extract that month and a year, and I can join my data that I have with the year and a month. That's what that part does there. Okay. Um, so that's fine. So I'm just gonna remove this. I'm gonna skim over this because it's just the same thing. It's just that here I'm focusing on GDP, gross uh, value added data. So it's just the same thing. It's just that I'm doing. The only difference is that this one was headquarters, so you needed to convert this to quarters and try to get from quarters to our data set. So that was, yeah, that was something else. But anyway, we did that. I think also this is gross value added data, and this is like the population in South Africa. So it's quite hard to get a population on a monthly basis. So the best I could do is to get a population on a year basis. So just to kind of like also show you guys how this one looks like. Um, so I'm just gonna display this DF So you can tell that this might be funny, but you will see it's still predictable. You know, you'll see that it still give us some accuracy a little bit. It still adds for accuracy, but yeah, this is how far I can get, guys. You know, but honestly, trust me. Like you can Google South African population. Yeah, it's quite hard to find this type of data, man. Trust me. Anyway, then we have weather data. This one I had to also scrape. I'll share with you guys the scraping uh, scraping, what is it, the scraping scripts, so that you can use actually scraping is one of the best skills that one can learn, you know. It's quite good. But anyway, this is weather data. As you can see that I have like month, sunshine. The assumption here was that, you know, when it's cold, maybe there's some relationship between demand there. I don't know, you know, we don't know, right? So you kind of like get everything and you say like, man, we'll see when we get there. That's what I was thinking, that's what I solved with that. But anyway, that's cool. We have all of this humidity, and so this is pretty cool, right? um yeah, then we have this data cleaning. So what I did here was that some of this data here that I'm joining on, you will see that actually I don't have data for instance here. I don't have data for 2023, and we are in 2023 and we need those features. So what I do is that I then like fill this, meaning that if there is a value, use the previous value. That's what it will do. So that use the previous. I can't do like something like imputation because I don't want like an average. Like we know population is always increasing, so you can't take an average. You for this data here, since it's forecasting, I want continuous data. All everything it has to be continuous. I can't take an average. I can't do that. At least in this case, I thought I can't do that, right? Maybe some of you guys have a better option, but for me, I thought like I just prefer continuous values if I'm gonna impute the data. I just want to take a pause here. I know that I might be going fast and some of the things that I'm cleansing here. If you are very new to data science and you don't know like the code and you don't know what I'm talking about, uh, check out my second channel. Like there was a project that I covered and explained like these things, and like I'll leave a link, and I'll leave the link to some of the best resources so that you can like learn the basics in Python and all of this code, so that you can get to speed, right? That I feel like that's what. Yeah. Anyway, we converting the holidays to 0 and 1, whether it's a holiday or not. That's fine. Then we creating these cyclical variables. So I didn't want to use the month. I just wanted to create cyclical variable from these these features that we created, like weekday, hours, and stuff like that. So I'm using the cosine and sine to do that. Then we have feature engineering. So what this code is doing is playing two roles. It's creating uh, our demand features based on like the temporal feature, which is time, um, and the feature that we want to product. So it's gonna capture the demand change, right? And we're trying to build features in the future. So I don't know if I'm making sense. Okay, let me try to make example. So let's say here, for example, let's say we're starting at like January 2023, right? And our data set ends at January 2023, maybe around June. Actually, June. This is not supposed to be, yeah, June 2023, right? This is our data set. It ends here, but we need to forecast all the way to August 2023, right? So we need certain features from here, right? We need the features that we used to make predictions to get here, right? So what we do is that we're gonna create a lag, which we're gonna create lags and rolling means, all of this stuff. So you can think of like we're gonna take the mean of the demand and we're gonna roll it all the way to August, right? We're gonna roll all of these stuff all the way to August so that we create those features so that when we forecast, yes, when we move from 20 June 2023, we go all the way to August, we have those features, we already have them. And I'm gonna show you how to do that. So this is a very, very powerful technique, right? That we do. So what do we do here? Not only it help us to kind of like build a very good model, especially in our when we're gonna test data set. So what we do here is that we have these legs. So this is gonna shift the the residual demand 24 hours, right? So then it's gonna be leg T24. Then this is gonna shift the residual demand 144, which is 6 days. Six, yeah, six. That's what I created. I created these features based on like Eskom forecasts within I think a week. So that's why I wanted to stay in the same ballpark. Um, and then we creating these rolling means and rolling standard deviations. Then here, this is very, very good in terms of like this technique to work for me personally. What I do here is that I capture the demand change. So I firstly take the lag, right? And then what I do is that I will then, okay, this is just converting the type because of you're gonna have a lot of challenges, especially with the types. But anyway, what I do is that I'm gonna subtract that lag from the demand, and I'm gonna divide by that lag. So it's just a change formula. So nothing special there, but we just want to capture the demand change. That's what it is, right? We're creating that feature for ourselves. So the thing is, the reason you're seeing a lot of code and it looks the same is because of I'm using different shifting values. Like it could be 72 hours, 144 hours, something like that. Um, by the end of the day, this is the type of data that we're supposed to be having. So I'm just gonna run this. So we're gonna have something like this. I want you to observe this data right here. So can you see this? This is like all of the features that we created now. But I want you to observe this, right? Which is quite important. Our data set ends on 2023 or 325, but we were able to go to the future, like 1 week ahead. So you see, 23 or 3 to 31. That is because we want to forecast using these features. These features here are essentially going to help us to make those predictions, right? So to be able to forecast like what the demand will be, right? So we kind of like have that. We still have that like the understanding of like what the demand was based on these features that we just computed. So you can like tweak these values, especially if you're gonna predict like for a month or 2 weeks. So it depends on what your goal is, but you can tweak them as you wish, right? So that's totally fine. um what I'm gonna do here, I think I'm gonna create a class, and I'm gonna probably create a class in a nice way so that you guys can reuse it across all your project. So that way it might be quite cool because you know that some useful function that you can always call. So we have this forecast data here. So you can think of this as like we're extracting all the features that we want to forecast with to the future. So if I run this, I think we're supposed to have something like 130 something rows. So I'm just gonna run this. So this is what we get. As you can see that, yeah, 134 rows. And if I go to the left, you can see all the features that we created, rolling mean and stuff like that. So we have captured essentially what you can think of this as this. We've captured the demand change, we captured the demand mean, all of these things around the demand, we've captured them, right? So which is cool. Um, then because we're gonna have to train our data set, so what we need to do is that we need to remove all of this. We need to remove the features that are going to be used to forecast. We don't want them. So that's what that code does there. And then I'm saying that, okay, all of these features are going to be used in the forecast data. So those are the ones. And for training, these are the features that we want, right? We want the capacity features, economic, social features, weather features, lag, rolling window features, date features, holidays, right? I did not use the supply features. I believe that a lot of people could have tried that and they got probably like a good accuracy, probably. But I wanted, like I said, I've been saying this. I just wanted to see if like we could explain demand based on other features that we kind of like came up with, right? So that's the prop. That's the goal. And I didn't actually try a lot of things in this case, guys. I want to be honest that if you are going through this code, you can literally try a lot of things. Like you can try like supply features, you can try like SG Boost. I used LGBM in this case. So there's a lot of things that I didn't try. So you can definitely like try and see what works and what does not work, right? So you can think of this as a more like a boilerplate for you to kind of like work on different experimentations. So yeah, we're creating our train X and train Y, and then because of I'm using tree-based models, normalization, they are not that strict on normalization, normalized values, so they can still work with like different scales. So that's still fine. But if you really feel like you wanna normalize the data and try to see the accuracy, that's still fine. You can try to normalize your data, um, all of this stuff. And I just want to pause and say that some of you guys might not understand what normalization is and all of this stuff. Like I said, check out my channel, my second channel, whereby I introduce some of these concepts and what they do. Uh, and I'll leave some of the resources to get into like these concepts, right? I feel like this is more like a project. It was not meant to be like some sort of like an introduction. If you guys want like an introduction video to machine learning, let me know. Then I'll create one, right? I just want to apologize for that because I feel like I might be skimming over some of the things and some people might not have idea what these are. So I feel a little bit bad there. But yeah, just I'll leave the resources to kind of like watch like the beginner friendly videos, right? Maybe some other videos I think you might need the fundamentals on. Anyway, so what we doing here is that I'm just like I'm just converting all these features to be a float. Only the features that are inside this float features. This is mainly because uh, I have to pass them through the model, right? And so if you're passing like object, I think it was gonna complain. So I'm just making sure that the data and the holiday residual demand, I don't wanna process that. So all the rest of the models can be processed. Then we're creating these parameters that we're gonna use. I'm using this objective function, which is 3D, very very powerful, very powerful. I've tried different ones, poison, and I've tried a regression. 3D for me was one of that I got like a better accuracy with in this case. Um, then we're creating these empty NumPy arrays because we're gonna store our results. into this, then we're gonna create columns from these. So and we're gonna create feature importance from these, so which is gonna be cool. This is just the training for loop whereby we're just trying to get the train and the validation data set and we pass them throughout our model, which is LGB model. Then we have this classifier and we're passing all of these parameters inside here. And we also have this test set, right, that we're predicting on. And yeah, so this is our feature importance. These are all the features that enable us to get a good accuracy overall. So we can see that a rolling mean T720, rolling standard deviation 720 was quite predictive. Look at all of these features that we added around. Um, Look at that consumer price index. It's not bad, right? I mean, uh, then we have sunshine per day. So yeah, not bad. I think like they're still within like the top range. Obviously, these ones are gonna dominate since they were based on the demand. So it's quite abnormal. But these essentially are gonna help us. The thing is, you might think that oh they're not contributing, but no, they are, because remember that essentially these it's more like you have the mean, you have some sort of like idea what the demand will be, right? It's like someone says that I think electricity is used a lot around 5 p.m. or maybe 6 p.m., right? Because of that person is thinking okay maybe people are cooking at that time, but now that's fine, that's like you have idea. So these features like I see them that way, but these ones here like you are your population, your weather data, they become very powerful, especially when like you go into different season within a year. Uh, let's say maybe it's a holiday and stuff like that, or maybe like the economy changes suddenly and the prices rise. And these features, that's where they step in. And I think they can become quite powerful also on that case. And this is what we have, guys. Not bad, right? We can see that actually this purple one. This is the one that we just trained. Then this residual demand. This is like the actual demand. Remember that here we just it's just a test. We're trying to test this, right? Then we have this residual forecast, which is Eskom forecast. Eskom also does forecasting, right? So we're comparing all of these three, and we can see that literally on the simple part, but slightly off. No, you should be on the exact same thing because some people like some people are like, oh man, like even like um if you're 100 off like or something like that, like it's not acceptable. I think I don't know, maybe your RMC will be less than 100 or 500, I don't know, but that's something that should be considered. So then what I do here is that we have this residual demand, and we have this is based on the weekly basis. Am I correct? Did I actually do that? Yeah, this is based on the weekly basis. Yeah, yeah. So we have the demand, same thing that we did, but here we're looking at it from a 1 week perspective. I just want to make sure. I'm just gonna glance at the time below here. Looks like this is just a day. Yeah, 24. So I'm just like, yeah, 24. I'm just looking at this from a day perspective. Actually, I think I was supposed to zoom in because I can't see. I don't know how you guys are gonna see actually. Yeah, that is, yeah. Anyway, this is a day. So yeah, as you can see that this is like the predictions that we just made now. Um, then now what I do is that I'm forecasting into the future. So I'm calling all of these, I'm creating all of these parameters that we had, like, all of this stuff. So all of those functions, I need them because I need to have the features to be able to predict into the future. So I'm gonna call this so that you guys have you can see how it looks like. This is what we have. So we're going into, so these are all the features that we have. You can see that these are all the features that are gonna help us predict the future. So we're gonna be able to do that. That's that. So I'm just gonna, you can see that there's already this column because I've already ran this. That's why there's this column here called demand. So this is like the predictions. But that's because I already ran this code here. So we're doing the same thing that we did on the training set. I'm just gonna, I'm just gonna, yeah, this is okay. Yeah, this is what we have. I'm just gonna scroll up. So we have these forecasting. Okay, yeah, this is what we have. So we are assigning this demand to this forecast. So we have this demand data set, and then we have this evaluation data set. I don't know if you guys still remember this. I showed you when we started. So these are all the forecasts that Eskom makes in the future. So we're gonna compare their forecast in the future with our forecast in the future. Okay, that's what we do there. This is the evaluation data set, and we're gonna match that so that we using this, so we can think of here we joining these two tables. Now if I call this, we should be having these two tables joined together. You can see here it's a residual demand forecast, and this is like our forecast. This is Escom forecast. Okay, so this is how it looks like. Yeah, gonna switch off this. So yeah, so here just a note to myself. So I was saying that on the back end, essentially what you happen is that when you're building applications, we have pagination, right? But so especially when people want to analyze data, right? Especially in like the data science of things, whereby you have like millions of rows and you want to analyze that data, all of it. That's where like you want to use like a data warehouse, like snowflakes, because they're columnar, instead of like squeezing something like MySQL or Mongo's DB or something like that. So those are like operational databases, right? So you might want to use them on like on a e-commerce, something like that, because realistically speaking, the like something like BigQuery, it has been optimized to work with like large data set, right? So you kind of like write, like you can like literally write SQL script to analyze like large amount of data. But now doing this on an application is not ideal, because now you have like millions of users querying your application coming to your website, and you want them to query like 100 rows from your from your database. It's not ideal. So that's why we have pagination on most of the applications, so that like a user can read like something like 6 rows or something like that, right? So um, what I'm saying here is that so if you want to go that direction, whereby you want to analyze, use those databases and use something like superset, a dashboard part. We're gonna get into superset. It's similar to, it's not similar to Power BI, but you're gonna like it. I like it a lot. Yeah, then you might want to go into that direction. But for application, like the one that we just built with nextJS, so you wanna like, you don't wanna like write like a lot of data. You don't want your users to read a lot of data, like millions of rows and hundred of rows and stuff like that. So so how we handle this is that we use this I use this the static site generation, and because of we create forecast like in a weekly basis, so you can use static site generation, and then the data is on the server. Then the user like is the data is cached. The user can just like the app is becoming more responsive, right? Like if you refresh this, it's fast, and it has like you can see this data is like for 2 weeks. So it's like um, it's quite a lot. It's like over 200 lines, over 200 rows, right? Something like 300 something rows, but it's very fast. Why? Because we have cached this. So it's not even reading from the database. So that's why it's so fast, right? So that's like the technique if you want to build like application like this. But if someone is an analyst and I want to like analyze data from 2018, then I'll say go the route of like very optimized data warehouse. Then you go the route of like superset. We're gonna get into it as much as we're gonna build these projects in the future, um, which is a BI dashboards and stuff like that. So it's gonna be quite cool. But yeah, static site generation is quite cool. So it essentially enable us to cache this data here, and so you can see that the data is cached on the user side. So it's very fast and responsive. Um, anyway, I removed my password here of the data because I'm using Postgres. By the way, guys, if you don't want to download Progress and do all of that, this is the go-to tool. Check it out. Railway essentially enables you to create a database like quick. You get a connection string, you paste it here, and you just like write to that database. So let me show you an example. So I'm just gonna um, click here, right? You can see that I have this weekly forecast tables, and you can see these are the tables. And if you go to the connection string, right? So what you see here is that I have this password, and you can come here and just copy the database URL. So and you come in here and you paste it here. Okay, so it's very cool. I'm gonna leave example of how you do that, but as you can see that I've removed the password here and stuff, it's just so that you know privacy, how it works. Anyway, this is cool, guys. You should check this thing out. It's either super base or railway. Essentially they enable you to create like Postgres, Redis, all of this database, and especially if you're working in development mode, you can just build something um, with the database very quickly. You don't have to kind of like download, and or you can, I mean, you can, but I'm just saying that it's very neat that if you wanna develop something in prototype, right? Anyway, that's fine. We're gonna write our the capacity. We're gonna write our forecasting data to the database, and what we're seeing here is that I'm just showing you all the predictions to the future that I've made. And the original demand that was already there, right? So the green thing is like the forecast, the future, and the orange thing is like uh, the residual, the actual demand that happened previously, right? So, yeah, that's that. Um, yeah, so now let's get into the app and try to see how the app works. And yeah, so now we have the application code. I built this, like I said, guys, with nextJS 13. So this nextJS 13 has this new app directory structure, which I really like it a lot. Like it's very good. I think especially if you want to create routes, essentially if you want to create route, like you build this folder here, and that's a route. So you can essentially go to your local host, then slash dashboard, just like that. So that's how neat it is. So and for the database ORM connection, I'm using this thing called Prisma. So Prisma is very neat. It creates your can create your migrations, um, and you have this client here, right? Which you can create to be global so that it can be able to you can be able to use it to reference your table names. So that's what I'm doing here. But you can think of this as like I don't know how you guys are familiar you are with like web development, but yeah, this is like the stuff that I used. Then I'm using for styling. I used Tailwind CSS. It's one of the most popular CSS. Is it framework? Yeah, that is being used today. Also, I really like it a lot. It's very neat. Then inside here, I have these components, and for my charts, I used recharts, right? Rechart for me, I enjoyed working with it. It makes things very, very easy and it's very intuitive. So I just like give it my data set as a list, and what it's gonna do is that I just need to call these an area chart, right? Uh, then I provide my AC, my X's, and it still allows me to write JavaScript, especially if, like, for instance, here, if you write, if you didn't do this, essentially you're gonna see your x-axis. You're gonna have like a lot of dates, month there overlapping, so it was not gonna be nice. And essentially, it gives you the flexibility to format it the way you want it. So I'll say like I'll leave the code for you guys to go through it, but you will see that essentially recharge. One thing I like about it, it's like the flexibility that it gives you. Essentially, you can like customize things the way you want, um, right? You can move the the names of the axes the way you want, right? Which is pretty cool. Then the code is essentially similar for these charts. As you can see for the line charts, essentially you just needed to provide like different parameters then there, but for the most part, I think it's still the same. Um, then just to then we have this page. So how it works, by the way, how Next.js work is that anything that is within this app directory is server side rendered, right? SSR by default. So what you need to do if you want to do it client side is that you need to use this thing called client. So if you can see my chart, they have this use client because of these chart are interactive, so they require you, right? So you need to do that. Uh, so I'll leave a link to Sunny's video. I think he explained Next.js 13 very well. It will definitely get you on board. So then I'm using this when I fetch my data. I'm using this cache. Essentially, this will enable me to cache the data, so that like you get to have that data like like it's very fast, like I showed you, right? So then you can have this also the ISR. So it's essentially the SSR is this revalidate the page after a certain time, especially if like that your app is changes data within maybe 60 minutes or so. You can also do that. So this is like the code to do it. Just say next, revalidate 60. So you can do that. So that's fine. Um, yeah, I'm not gonna get into a lot of details around here. Um, if you guys wanna like I said, I'll leave the code so that you guys can go through it. But yeah, this is what we have. Then with the APIs, essentially Next.js allows you to have your APIs. So here you can see that I'm reading from the database and I'm creating these get, and these can be called within Next.js. So Next.js, that's why a lot of people they call it a full stack, because you can work with your database, you can create a API, your backend, so which is pretty cool. Yeah, I think that was a walkthrough, guys, of the whole entire project. Um, I really appreciate it. If you watched to this end, I'll see you guys in the next one. Thanks. Bye.